Hi everyone, this is this first lesson in our last unit, Unit 5, and it's on amortization, mortgages, and bonds. Okay, that's what this unit is going to talk about. And we're going to see kind of how the stuff we've been doing so far, annuities and compound interest, fits in these types of real-life scenarios, specifically in this lesson looking at amortization. So amortization is for anything that has interest, whether it's a mortgage, a lease on a car, they're amortized, okay, if the principal and interest are paid off in a series of payments made at equal intervals. So that sounds like an annuity, right? Equal payments, equal intervals, right? That's because the formulas for annuities are what we use when we're trying to calculate amortization, okay? Specifically, what we're looking at is the periodic payment formula. Okay, so we're going to focus in on one aspect of an annuity, and in this lesson, we're going to look at simple annuities, okay? And we're going to see how we can take that payment that we calculate and break it down into its components so we can understand better what that payment means and how it's actually being applied to our loan versus interest that would be paid to the bank or paid to whoever you're lending through, okay? So if you remember back for a simple annuity, for amortization, the only thing we care about is present value. So when you have something that's amortized, okay, and in this case, what we're looking at in our examples, it's usually a loan, okay? So if you purchase a car for $30,000, or if you're purchasing a home, or you're purchasing an RV or a boat, okay, any of those items that you have a loan, okay, that loan is being paid off over a period of time. And to do that, in all of our examples, you remember, we've tried to find the payment, the amount that you pay every interval, whether it's monthly, quarterly, semi-annually. In most cases, you'll see in real life it being monthly or being bi-weekly as examples. But you use the present value formula, or the payment formula, I should say, where you know the present value to calculate the payment. So what you'll see is this formula here for a simple annuity finding payment is going to be the building block for each example that we do in this lesson. So my first example, I just want to do a refresher. Okay, simple annuities was all the way back in Unit 2. So I'm going to do one example of finding the payment for a simple annuity next before we start discussing what that payment means in terms of its individual components. So our first example is what payment should be made semi-annually at the end of each period to pay off a loan of $8,000 in 10 years if interest is 10% per annum compounded semi-annually. Okay, so a couple things you'll notice here. Interest is semi-annual and so is payments. Okay, so again, this is a simple annuity. And you'll see that it's a loan. And remember, what I've been saying all course is that the present value is what's provided in the question when you have a loan. Okay, because you take out a loan, in this case for $8,000 today, and you're paying it off in intervals. All right? So if we're just looking at calculating payment, remember our formula from the last slide, the payment is equal to the present value for a simple annuity. That's why I have this subscript N. Multiplied by the periodic interest rate, again, because this is a simple annuity, not a general annuity, divided by 1 minus 1 divided by 1 plus the periodic interest rate to the exponent n. Okay, again, this is just a simple annuity. It's not an annuity due or anything special. Okay, the original scenario we talked about in Unit 2. So our variables, again, our present value was given in the question, $8,000 for our loan. Our nominal interest rate, J, is 10%, which is 10 divided by 100, removing the percentage sign, or 0.10. Our number of compounding periods, it's semi-annual in this case, so M is 2. So our periodic interest rate, I, is J divided by M, or 0.10 divided by 2, which gives you 0.05. Our last item we need is the number of compounding periods, total number of compounding periods, N. And that's equal to the number of years of the loan, in this case, looking at the question, 10 years, multiplied by the number of payments each year. Okay, so in this case, it's semi-annual, so 10 times 2 gives you a value of 20. So if we substitute these values into our formula, our payment is equal to our present value, 8,000, times our periodic interest rate, 0.05, divided by 1 minus 1 divided by, and then 1 plus the periodic interest rate, 0.05, to the exponent 20. And if you calculate this value out, you'll get a payment of $641.94. Okay? So, knowing this value, I'm going to show you in the next couple slides what this number means. Okay, so what this means in terms of how much of this is actually paying off your loan of $8,000 and how much of it is interest that's going to the bank or going to whoever is financing you. Okay, because remember, if you have a loan like that, they're charging interest so they can also make money off that money that they're giving to you. Okay, so they need to make money as well. So if we start looking at breaking down the periodic payment, what exactly are we looking for? So within your loan, there's going to be a few parts, okay? So the principal is the actual sum of money that's earning interest. So that's basically the amount you took out for your loan. So in the example of our last question, your principal was $8,000, okay? Interest is what we call the rent charged for the use of that money. In other words, it's the amount that whoever loaned you the money, whether it's the bank or an external company, whoever loaned you that money, that's the interest of the amount of money they're making on this transaction. Okay. The last term that we're going to see is called the outstanding principal balance. Okay. So every time you make a payment, there's two aspects to it. So that payment, in the case of the last example, $641.94, part of this payment will pay off your principal or will reduce the amount of money that you have outstanding for your loan, and part of it will actually pay into the amount of interest that that company is earning. Okay, so we're going to look at a couple of examples in the coming slides. I'm going to work in a little more detail the example we just did in the last slide. I'm going to show you how to break that payment down into its components. So let's look at another example where we break it down. You have a loan for $8,000 and interest is 6% per annum compounded monthly over a 5-year period. So part A is what is the size of the monthly payment. Part B is what is the total amount of the loan, including interest. And part C, what is the cost of financing, or what is the interest on the loan? Okay, so we're going to break down this total value before we start seeing how the payments break down on an individual payment basis. Okay, so first question is just like part A is just like our first example. So we're trying to find our payment. So that's equal to the present value. Again, this is a simple annuity because it's compounded monthly. Okay, so we're assuming that in this case it's a simple annuity unless I tell you otherwise, all right? So the payment is the present value for simple annuity times the periodic interest rate divided by 1 minus 1 divided by 1 plus the periodic interest rate to the exponent n. Okay, so if we're trying to find each of the values for this, all right, I'm going to do a little sidebar here. Our present value for the loan is $8,000. Our nominal interest rate, J, is 6%, which is 6 divided by 100, removing the percentage sign, or 0.06. M is equal to 12 because we're compounding monthly. So our periodic interest rate, I, is J divided by M, which is 0.06 divided by 12, or in other words, I is equal to 0.005. Lastly, our value for N, so the loan is 5 years, so 5 multiplied by 12 payments a year gives us a total of 60. So for part A, our payment, if we substitute these values in, is equal to our present value, $8,000, times our periodic interest rate, 0.005, divided by 1 minus 1 divided by 1 plus the periodic interest rate, which is 0.005 to the exponent 60. And if you calculate that out, you'll get a payment of $154.66. Okay, so that's the payment you're making each month. And remember, you'll have 60 of those payments to pay off this loan. So part B is, what is the total amount of the loan including interest? So think about it. If that total loan is just however much you are paying each payment multiplied by the number of payments. So in part B, it's $154.66 multiplied by 60 payments. And if you do that, you get $9,279.60. So you'll notice that it's a lot higher number than the original loan of $8,000. And that's because interest is being charged monthly, okay, over this entire 5-year period. So what that means is, looking at part C, what is the cost of financing? In other words, the interest on the loan. Well, you were given $8,000 as a loan, but you're paying back a total of $9,279.60. So the difference between those two is how much you're paying in interest, or in other words, the cost of obtaining that financing. Okay, so you didn't just have that $8,000 lying around, you had to get it from somewhere else. So the cost of that would be equal to however much you're paying, in this case, $9,279.60, minus the amount that you received in the loan, so $8,000. So that means your cost is $1,279.60. Okay? So that means, what that's telling you, and we're going to go into a couple more examples, is that part of every one of these payments pays off your interest, but it also pays off your loan. Okay, so this $8,000 is your principal, and this value is your interest. Okay, so let's kind of look and break this down a little further. Your car loan is $4,600 and interest is 12% per annum compounded quarterly for 4 years. Part A is, what is the size of your quarterly car payment? Part B is, what is the total amount paid on the loan? And part C, what is the cost of financing, or in other words, interest on the loan? Okay? So just like our last example, we're breaking this down again just so you can get a little more detail and just see another example. So part A, okay, we want the payment. So our payment, again, is equal to our present value times our periodic interest rate, divided by 1 minus 1 divided by 1 plus the periodic interest rate to the exponent n. And again, I'll do my sidebar over here. So your present value of your loan is $4,600. Your nominal interest rate, J, is 12%, which is equal to 12 divided by 100, or 0.12. M, your number of compounding periods, is compounded quarterly, so M is 4. So your periodic interest rate, I, which is J divided by M, is 0.12 divided by 4, or 0.03. The last term, N, okay, your loan is for 4 years, and you're paying 4 payments per year because it's quarterly, so N is 16. So substituting these values in, your payment is equal to $4,600 times your periodic interest rate, 0.03, divided by 1 minus 1 divided by 1 plus the periodic interest rate, 0.03, to the exponent 16. Okay? And if you calculate this payment out, you get $366.21. All right? Just like in the last example now, in part B, what is the total amount you paid on the loan? Okay, including interest. So again, you're paying $366.21 every quarter, and you're paying it 16 times. So if you multiply those out, your total cost is $5,859.36. And remember, your loan was only $4,600, right? So in part C, what is the total cost of financing, or the interest? It's just the difference, $5,859.36 minus the amount you were given as your loan, so $4,600, which gives you $1,259.36. Okay, so in this case, it's costing you a lot of money. Okay, almost $1,300 for a car loan of $4,600. Okay. So now that we've learned how to calculate the interest, all right, I keep talking about breaking the periodic payment down further. What I'm going to look at is the outstanding balance on the loan. Okay, so what we're going to talk about is what's called the outstanding principal balance. Okay, and like I've said in the past, what you've seen is that some of your payment will go to interest and some will go to the principal. But the question is how do we separate that? So I've written out this example just so you have it in your slides when you print them out or whether you're looking at them on the computer while you're studying. So we're going to go back to this first question. You have a loan for $8,000 and interest is 6% per annum compounded monthly over a 5-year period. So in case you're wondering, all right, this is example number 2. So if you remember back, our periodic payment was $154.66. Our periodic interest rate, I, was 0.005, okay? So what that meant is that every single period, you're paying 0.05%, 0.005 or 0.5% on whatever amount in your principal you have left, okay? So for your first payment, if you have a loan of $8,000, on your first payment, you're paying $8,000 times your periodic interest rate. In other words, 0.05. Or in other words, you're paying $40 in interest. Okay? But remember, the payment was $154.66. So what that means is the rest of that payment is the amount you're actually paying off of the actual loan value, in this case, $8,000. So that means is your payment, $154.66, minus the $40 in interest, means that $114.66 of your payment goes towards the actual loan, right? Because your overall goal is to pay off that original amount that you borrowed. So for your next payment, your outstanding principal, again, we're talking about the outstanding principal balance, must be $8,000 minus that amount you just paid off. Or in other words, when you look at your second payment and you're calculating interest, the principal is $7,885.34. Okay? So with each payment, you reduce the amount of your principal balance or your loan. And what that means is that as you pay it off, less of your payment or less of the $154.66 goes towards interest and more starts going towards the actual balance of your loan. Okay, so I'm going to go through 3 examples where I actually show you how to calculate them. The first example looks at figuring out exactly what we did here. And the last 2 examples are going to look at, okay, how do I continue that forward and look at my second payment, okay? So let's look at the first of 3 examples where I go over how to break down the payments, okay? So you bought furniture with a loan of $5,000 with interest at 9% per annum compounded monthly over a 2-year period. Part A is what is the size of the monthly payment. Part B is what is the interest amount on the first payment. And part C, what is the outstanding principal balance after the first payment. So again, like I said at the start of this lesson, finding the payment is definitely the building block of developing these. So we start with our formula. payment is equal to the present value, okay, times our periodic interest rate, divided by 1 minus 1 divided by 1 plus the periodic interest rate to the exponent n. So again, with my little sidebar over here, our present value of the loan, okay, it was $5,000. Our nominal interest rate, J, is 9%, which is 9 divided by 100, removing the percentage sign, or 0.09. M, in this case, is 12, because it's compounded monthly. So our periodic interest rate, I, is J divided by M, which is 0.09 divided by 12, where I is equal to 0.0075. Okay, our last term, N, this is a 2-year loan, so 2 multiplied by 12 payments a year is equal to 24. Okay, substituting these values in, our payment is equal to our present value, $5,000, times our periodic interest rate, which in this case was 0.0075, divided by 1 minus 1 divided by 1 plus the periodic interest rate, 0.0075, to the exponent 24. Okay? If you calculate that value out, you'll get a payment of $228.42. All right? So now part B is looking at what is the interest amount on that first payment. Okay? So our loan is $5,000. We haven't made a payment yet. So on our first payment, we're paying interest on that total amount. So our interest is simply $5,000 multiplied by our periodic interest rate, right? Because that's the amount, that's the interest rate for each of our periods. So in this case, it's 5,000 times 0.0075, right? Our periodic interest rate, I. And that gives us a value of $37.50. So that's the interest on our first payment. Part C is asking what the outstanding principal balance is after the first payment. Okay, so remember our principal is the amount we had at the start of our loan, $5,000. So in order to calculate that, we have to figure out how much of our initial payment was actually on principal. So we know our payment is $228.42, and we have to subtract the amount that we're paying as just interest, right? Because it doesn't pay off the actual loan. So we subtract $37.50, and that gives us a value of $190.92. So after the first payment, that means that we've reduced our loan from $5,000 to $5,000 minus $190.92, right? The amount after our first payment goes towards our principal. And if you calculate that out, you get $4,809.08. So after the first payment, that's how much we have left over. So this cycle, what you'll see in the next examples, continues. And then this number for your next payment is how you would calculate your interest, which we did in part B. So instead of this being $5,000, it would be $4,809.08 multiplied by that interest rate. Okay, so our next example, we'll start to look at that. So our next example, your car loan is $35,000 and interest is 3% per annum, compounded monthly for 6 years. So part A is what is the size of your monthly car payment? Part B is what is the interest on your first payment? Part C is what is the outstanding principal balance after the first payment? And part D is what is the outstanding principal balance after the second payment. Okay, so again, starting with our building blocks for these questions is payment. So payment is equal to our present value times our periodic interest rate divided by 1 minus 1 divided by 1 plus the periodic interest rate to the exponent n. Okay, so again with my sidebar, our present value in this case is $35,000. It's your car loan. Your nominal interest rate, J, is 3%, which is 3 divided by 100, removing the percentage sign, or 0.03. M, in this case, is monthly, so it's equal to 12. So your periodic interest rate, I, is J divided by M, or 0.03 divided by 12, which gives you 0.0025. Our last item, N, okay, so this loan is for 6 years, and you're paying 12 payments a year, so N is 72. Substituting these values in, your payment is equal to 35,000 times 0.0025 divided by 1 minus 1 divided by 1 plus, again, the periodic interest rate, 0.0025, to the exponent 72. And if you calculate this out, you get a monthly payment of $531.78. Okay? So just like in our last example, to calculate the interest, again, this is at the very start, assuming you haven't made a payment yet. So on your first payment, the amount of interest you're paying is $35,000 multiplied by the periodic interest rate, 0.0025, which gives you $87.50. So what that means is, for part C, your outstanding principal balance, you have to determine how much of your payment is actually paying off this car loan. So your payment is $531.78, and we just figured out that $87.50 is the interest. You have to subtract that off to figure out how much is actually reducing this loan. So if you subtract that, okay, you get $444.28. Okay, so if you do that, now you have to subtract that value from your principal. So in this case, our principal, it's our first payment. The loan we took out is $35,000. We haven't made any payments yet. And then we can subtract the amount that comes off as principal. Okay? And if we do that, you get $34,555.72. All right? The interesting thing to note is if you have items like a mortgage, you can actually see this breakdown for your mortgage. Okay? Or if you want to, which is what I'm going to show you as part 2 of this lecture, you can actually do those calculations yourself using Microsoft Excel. So now part D, okay, what about your second payment? All right, so on part D, our interest, again, it's the same calculation as part B, except we have to use the amount that's remaining on our current loan. Okay, so we've made our first payment, and our second payment, our interest, would be $34,555.72, or how much we have left on our principal now, multiplied by that same periodic interest rate, 0.0025. Okay, and if you calculate that out, you get $86.39. Okay, as you can see, it's a little bit less than our first payment, but that makes sense, right? Because we have less money owing now. So as you have less money that you owe, the amount that you pay on interest decreases. And what that means is if we want to know how much we're paying off of our loan, all right, our payment doesn't change over the entire course of this loan. Okay, it's $531.78. But in this case, we're subtracting a lower amount of interest, $86.39. So in this case, for this payment, the amount of principal we're paying back is $445.39. Again, as you can tell, it's a little bit higher, right? Because we're paying off a little bit less interest. So finally, our outstanding balance must be $34,555.72 minus this principal, so $445.39. And if we do that, we get $34,110.33. Okay, so what you'll see is as you make payments, the amount you're paying for within each of these payments, in this case, within each of these $531.78 payments, the amount of interest will decrease and the amount you're paying off of your actual loan or your principal will increase. Okay, so let's do one more example of this. You bought a motorhome for $120,000 for your family, and interest is 6% per annum compounded monthly for 15 years. So again, part A, what is the size of your monthly motorhome payment? Part B, what is the interest amount on your first payment? Part C, what is the outstanding principal balance after the first payment? And part D, what is the outstanding principal balance after the second payment? So just like the last question, part A is finding your payment. So your payment is equal to your present value times your periodic interest rate divided by 1 minus 1 divided by 1 plus the periodic interest rate to the exponent n. So on my little sidebar, my present value in this case is large, $120,000 when you bought a motorhome, after all. Your nominal interest rate, J, is 6%, which is 6 divided by 100, removing the percentage sign, or 0.06. M in this case, again, is monthly. You'll see a lot of these examples having monthly payments, and that's just because I'm giving you examples where it'd be common that you'd see in real life, where you have monthly payments on a car, or a mortgage, or a motorhome, or a four-wheeler, or a trailer, or something, okay? So your periodic interest rate, I, is J divided by M, which is 0.06 divided by 12. And that gives you a value of I of 0.005. Lastly, your total number of payments, N. In this case, we're paying for 15 years, and you have 12 payments a year, and that gives you a value of 180. So if I substitute all these values in, your payment is equal to your present value, 120,000, multiplied by the periodic interest rate, 0.005, divided by 1 minus 1 divided by 1 plus 0.005 to the exponent 180. And if you calculate this out, you get a payment of $1,012.63. Okay? So now for part B, what is the interest amount on your first payment? Again, just like last question, we haven't made a payment yet, so our principal is the full amount, $120,000. That's all the money we took out to buy this motorhome, multiplied by your periodic interest rate, 0.005. Okay? If we calculate that out, we get $600. Now, for part C, okay, what is the outstanding principal balance on your first payment? So we know that the interest is $600. So the principal that we must be paying on this first question, or first payment, sorry, is the payment $1,012.63 minus this $600. So that means we're paying $412.63. So what you'll notice here is that more than half of your payment is actually going to interest, $600 versus only $412 to principal. And that is something you'll see is very common for long loans. Okay, a great example of that is having a 25-year mortgage. When you start your mortgage, most of your payment will actually go to interest. Okay, so finishing part C, it means that we have $120,000 in our principal, and we paid off $412.63. So we're left with $119,587.37. So again, with each of these payments, because it's such a long loan and a large quantity of money, you're not reducing the principal that quickly. Okay? Now, part D, what is the outstanding principal balance after the second payment? Okay, so again with interest, we start with our outstanding principal, which in this case was $119,587.37. $587.37 because we've paid part of it off with our first payment. Multiplied by our periodic interest rate, 0.005, and we get a value, okay, of $597.94. So just a little bit less than what we had on our first payment. So that means our principal that we've actually paid off, our payment again remains the same, $1,012.63, minus this interest, $597.94. So in this case, we're paying $414.69. Again, just a little bit more in principal than the previous payment. And again, this trend you'll see continues. So what that means is our outstanding balance, principal balance, is $119,587.37 minus what we're paying off in principal for this payment, $414.69. And that's equal to $119,172.68. Okay, so you can continue doing this on and on and on for every single payment until you're done paying it off. That's called an amortization schedule. Okay, so I've showed you how to do by hand, okay, the first payment and the second payment calculations. So in this next part that I'm going to show you, I'm going to show you how to do it in Microsoft Excel. Okay, so that is the end of this part of the lecture. So again, I'm calling this part 1. So I am doing a part 2, which will be just like previous videos where I record my screen on Microsoft Excel. Okay, so it'll be a separate video with a separate link. Okay, in the meantime, these are your practice problems. This was chapter 14.1. Okay, thanks everybody, and I hope you watch part 2.